So this is Protodrive, our ESC350 final project. Basically, Protodrive is the first step in a larger project to build a modular, small-scale electric vehicle powertrain, and then use this to prototype new powertrain architectures and also simulate drive cycles and range, and to be able to do this more cost effectively than doing it in a real vehicle. So what we have over here on our board is, on this side, this half represents the actual vehicle. So this would be a vehicle motor, the vehicle batteries, which in this case we're using 18650 lithium ion cells, the same cells that are used on a Tesla Roadster. We've also got a supercapacitor which we're experimenting with as part of a new architecture. The motor is controlled by it's a brushed DC motor, so we've got a brushed DC motor controller with a regen function. And this is all ultimately controlled by an mLAB microcontroller. Now on the right hand side we've got what we're calling the vehicle load. This represents the forces on the vehicle. So if it's going up a hill, it's the force that is placed on the vehicle by gravity. If it's just going along regularly along a flat road, it would be the air resistance. If it's accelerating, it's the force of acceleration. So what I'm going to do is run a quick simulation program to show you how this works, and then while this is running we'll point out some of the features of Protodrive. So I come over here to mLAB. We've got our GUI running, and this is talking to the mbed. And I hit play, and what you see on the top graph, that represents a slope. So right now we're simulating going up a hill, and in this condition you'd see a constant high torque. The graph below that is the speed of the motor. So they've just gotten started, and if we pan the camera over here, we can see our custom coupler and motor mount running there. Now at the top, if we come back to mLAB, we've just entered a constant, a flat zone. So right now the only force on the vehicle would be the force of the wind and maybe some rolling resistance. And what you notice is that the speed increased as we transitioned into this flat section. What we're doing now is we're simulating going down a hill, and if you come back to the drive, we have these arrows which indicate the flow of current, and you can actually see that current is coming from the load to the vehicle. So this represents regen as you're going down a hill. So it's actually using the brakes to generate energy that recharges the vehicle's batteries. Just to end off, I'm going to point out some of the design features of this board that make it ideal for prototyping. First of all, we've got these modular sections for the load, the vehicle and the motors, and these are really easy just to pop this open, and very quickly I can swap out a completely different motor. We've also got safety switches on the batteries to turn those off when you're doing experiments, and on a main kill switch for the entire circuit. So if I flick this, everything turns off and it goes back into this demo mode where it's just running the lights. Beyond that, we've got a breadboard which makes it real nice for prototyping, and a handle which makes it very convenient to carry.